Hey everyone, so in this video we're going to continue on with talking about the z-test to be able to find confidence intervals. So example 2. From a random sample of 40 days in the previous year, the mean temperature in Houston was found to be 82 degrees Fahrenheit. If the population standard deviation of temperatures in Houston is 14.5 degrees, construct a 95% confidence interval for the mean temperature in Houston. All right, so we're going to go through and fill out our panic first. So for P, that was our parameter of interest. So in this case, we're trying to find the mean temperature in Houston So mean temperature in Houston. All right, and really I should say the population mean temperature in Houston. All right, the A stands for assumptions and conditions. So first off, it is random. Second, we either need it to be normally distributed or n is greater than or equal to 30. Now, in this case, it doesn't say anything about being normally distributed. However, we took a sample of 40 days. So n equals 40. Well, that's greater than or equal to 30. So we got that condition covered. And lastly, we need to know if we have the population standard deviation. And in this case, yes, we do. So sigma is known. All right, so as long as sigma is known and those other two conditions are true, then we're using the z-test. All right, so for I, we need to find our interval. So we're going to head over to Excel. And now that we're here in Excel, we have everything right here. Again, at home, you have your notes right next to you, so you should be able to see all of this in the problem anyway. But our mean was 82. Our population standard deviation was 14.5. The confidence that we want is 95%. And we took a sample of 40 days, so n equals 40. So, all that said, to find our E, we're going to do equals confidence dot norm. And the first thing it needs is alpha. So remember, alpha is 1 minus your confidence. So if confidence is 95%, then just to show it off to the side real quick, it would be 1 minus 0.95, which gets us 0.05. All right, so confidence.norm of 0.05. Our standard deviation is 14.5, and our size is 40. Hit enter, and there is our margin of error. So to find our actual interval now, we're just going to do equals the mean minus E for our lower, and then equals the mean plus E for our upper. And this gets us our lower and upper bounds for our interval. All right, so we're going to head over back to the notes. And if we round those to 2 decimal places, we got that it's 77.51 to 86.49. So all that's left to do is to state our conclusion. And remember, this is just fill in the blank. All right, so it's with our confidence, which was 95%. So with 95% confidence, we can say that our parameter, so the population mean temperature in Houston is between, and then we put our interval, 77.51 and 86.49. And we're done with that problem. So let's do one more like this. So example 3. A random sample of 20 US men showed their average height was 71 inches. The population standard deviation for men's height in the US is known to be 3 inches and normally distributed. Find a 99% confidence interval for the mean height. All right, so starting off with our parameter of interest, we're trying to find the population, it's going to be the average height for men in the US, so the population mean or average height for men in the US. So next up is our assumptions and conditions. All right, so first off, it is a random sample. So we got that first assumption down. Secondly, we either need it to be normally distributed or n greater than or equal to 30. N is not greater than or equal to 30 in this case, it's only 20. However, it is normally distributed. So normally distributed. And lastly, we need to know if we have the population standard deviation, and yes, we do. It is 3 inches, so sigma is known. All right, next up, we name our test. So since sigma is known, we are using the z-test. I is our interval, so we're going to head back to Excel. So in Excel, we have the stuff that's given in the problem, which this was example 3, not example 2. There we go. So the mean from the problem, that was 71 inches. Our standard deviation was 3 inches. Our confidence interval that we want is 99%. And n was 20 because we had a sample of 20 men. So real quick, our alpha, remember, is just 1 minus our confidence. So it's going to be 1 minus 0.99. So our alpha is going to be 0.01. All right, so let's go ahead and get our margin of error. So remember, it's going to be equals confidence.norm of our alpha, 0.01, our standard deviation, which is 3, and our size, which is 20. So we get a margin of error of about 1.73 inches. So to find our lower bound for our interval, it's going to be equals our mean minus our margin of error. And for the upper bound, it's going to be equals our mean plus the margin of error. And so here is our interval. Don't forget, we are going to round these to 2 decimal places. So let's go back over to notes and get this down. All right, so our interval was 69.27 to 72.73 if we round it to 2 decimal places. So lastly, we just need to do our conclusion. So our conclusion is going to be with our level of confidence, so 99% confidence if I can spell, there we go, we can say that our parameter, so the population mean height for US men is between 69.27 and 72.73. All right, one last thing we need to cover, and that's going to be finding the minimum sample size needed to estimate a mean. So to find a sample size large enough to be able to estimate the mean with a confidence of C, so that could be like 90% confidence, a population standard deviation of sigma, and a margin of error E, you can use the following formula. So we have N equals Z sub C sigma over E all squared. Now, this part, Z sub C, is the critical value for that level of confidence. So it's the Z-score that the area between negative Z and Z is C. All right, so if C was 90%, then this is the Z-score that 90% of the data is in between negative Z and Z. All right. Now, once you do this calculation, if it ever comes out to a decimal, we are always going to round up. It doesn't matter if it's 25.00001, we are still rounding that up to 26 if it has any decimal after it. All right, so let's go ahead and get started. We're going to be pretty much doing this all in Excel. I will show you how to kind of come over here and do it by hand if you want to do it by your calculator instead. However, it's easy enough just to go ahead and do it all in Excel, so you might as well. All right, so for number 4, find the minimum sample size N needed to estimate mu for the values C equals 0.9 or 90% confidence, sigma equals 6.8, and E equals 1. So let's head over to Excel. All right, so we're first going to need to figure out that Z sub C in the formula. All right, so we're going to need to find that Z score. So in order to find that, we're going to do the same thing that we did a couple assignments ago. All right, all we need to do is find the lower end, the area under that curve. All right, so if it's 90% in the middle, then that means 1 minus our 0.9. Oops, it would help if I put equals in front of it. It's going to get us 0.1. But that gives us both tails of our normal curve. We only need the lower one, so we're going to divide that by 2. All right, this is the area that's below the Z-score that we're looking for. All right, so to find it, we're going to do equals norm dot INV, so inverse. The probability is going to be 0.05. And we're just using the standard normal distribution here. So the mean is 0. Standard deviation is 1. All right, hit enter. And we get negative 1.64485. Now, we just want the Z itself, not the negative. So I'm going to do one more thing here just to turn it positive. And that's going to be, I'm going to put ABS and parentheses around this whole thing. All that does is it takes the number and it makes it positive. Didn't change the number at all, but it made it positive. All right, so we have everything that we need now. So we can calculate our N. Now, this formula is kind of weird looking whenever you put it in Excel, but it's not too bad. So this formula is just going to be equals, we're going to put an opening parentheses, you'll see why in just a second. Then it's our Z-score, which is right here, times our sigma, which is right here, divided by E. I'm going to close the parentheses, just like the formula has it. Then we need to raise it to the second power. So to do that in Excel, we're just going to put caret 2. Hit enter, and we get 125.1043. All right, now I'm going to take that number back over there, but remember, we need to just round this up to the nearest integer, so we're just going to use 126. All right, that is going to be our answer, but let's go back over to the notes real quick. So we got n equals 126. All right, now really quickly, I did want to show you that you can do this, that last part at least, without Excel. You still need Excel to find the z-score itself, but after you find the z-score, if you really don't like Excel, you can just plug all this into your calculator. So we can just use those numbers that we found in Excel along with the numbers that we have here and plug it into the formula ourselves. So again, plugging into the formula, z-score first. So the z-score that we found was 1.644854 times our sigma, which is 6.8, divided by e, which is 1, square all that, and again, you're going to get 125.104 blah blah blah, but it doesn't matter what the rest of those decimals are because we just ran up to the nearest integer, so again we get 126 for n. Alright, so again, if you really don't like the way that formula looks in Excel, do it like this, plug it into your own calculator, it's no big deal. Alright, just do try to grab as many decimals from Excel for the z-score as possible, because if you start cutting off that z-score, it does start changing your answer pretty fast, and you're going to get a little bit of error in your answer. Alright, last one. So example 5, same thing, we're going to find the minimum sample size n needed to estimate mu for the values of c equals 0.8, sigma equals 4.1, and e equals 2. So let's head back over to Excel. Alright, so this is example 5. So our c equals 0.8, sigma equals 4.1, e equals 2. First thing we need to do is find that z-score. So remember, it's going to be equals 1 minus our c, so 0.8. That gives us the area under both tails at the ends of the normal distribution, but we only need that one tail that's on the left. So we take that value and we divide it by 2. That's the area that we want to use for our z-score. So we're going to do equals norm dot inverse. Our probability is going to be the 0.1. Again, we're using the standard normal distribution, so our mean is 0 and our standard deviation is 1. And we get a z-score of negative 1.28155. Now, again, we don't need it to be negative, so I am just going to go ahead and change that. For the record, as long as you put everything incorrectly, it shouldn't change your answer even if you do keep it negative, but in general that z sub c is positive. So I'm just going to go ahead and put absolute value surrounding what we already had there. Again, all it did was take that negative off. Alright, so now to find our n, equals parentheses our z-score times sigma divided by e, close the parentheses, and then square it by doing caret 2. Hit enter, and we get 6.9, which is going to round up to 7. So one last time, let's go back to the notes. And we found that n equals 7. Again, if you would like to do it this way, you're more than welcome to. I just figure since we're already in Excel, might as well finish it off in Excel. All right, and that is it for this set of notes. So I will see you in the next assignment of notes. Bye, guys. Actually, one last thing before I do go, which I'm sure half of you already clicked off this video, but just to remind everyone, what I'm talking about whenever I'm getting that 0.1 in this problem is we have, 80% in the middle. So 80% is that part in the middle. So if we do 1 minus that, we get both edges as 0.2, or 20%. But we don't need that side. All right, we just need this one over here. So if we just need that one over there, then we're dividing that by 2, and that's where we're getting that 0.1 or the 0.05 in the first problem from. All right, so just a quick little reminder about that, just so you know, and just so you haven't forgot how to find that z-score. All right, that said, I really am done now, so I will see y'all guys in the next video. Bye.